Assalamu alaikum. This is the chapter 6 in which we covered the first part of it, and we would like to divide this chapter into three parts so that we can have smaller videos uploaded to Blackboard. In the first part, we covered the first three topics and also some of these array types. In this video, we will talk about the rest of the array types, and then we cover associative arrays, the record types, the tuple types, the list types, the union types, and also pointers and reference types. In the third video, we will cover the rest of these topics, which is about optional types, type checking, strong typing, and then type equivalence, and theory and data types. So in this video, I would like to start talking about the rest of these array types, in which we'll talk about multi-dimensional array and how to access these multi-dimensional arrays. We covered the multi-dimensional arrays earlier. Now we're talking about how to access these dimensions, how to access these array values. There are two different ways to access the multi-dimensional array, which we call them row major order and column major order. The row major order يعني by rows, and the column major order يعني by columns. So the row major order by rows, it's used in most programming languages like Java, C, C++, and other scripting language as well. While the column major order it is used basically by Fortran, which is a language that use the multi-dimensional array in basically slightly different way than other major programming languages. But for these languages, we have what we call compile time descriptor for multi-dimensional array, in which we can see that the array, it has its name, it has as element and the data type of the element, data type of the index itself, and the number of dimensions for multi-dimensional array, and also the range, the index range, which is start from 0 until n-1, such that 0 is the first element of the array and n-1 is the last element of the array. If we'd like to compare between these array in terms of accessing their values, we can compare between single dimension array and multi-dimensional array, in the sense that in the single dimension array we have the array, the type of the element, it's the data type of the element, and the index type, which is basically an integer, because we talk about the position in which that array takes, position 0 or position 1 or position 2 and so forth. Also, we can talk about the index lower bound and the upper bound, and also the address of that array, which is the memory location where the value of the array sits. While here in the multi-dimensional array, we can extend that more by talking about number of dimensions. The dimensions basically is in like in the two-dimension array, or in the second dimension array or two-dimension array, we can talk about the number of dimensions in which this value sits. So for example, we have the rows descriptors and the columns. This is to access it by row, and this is to access it by column, like vertically. But the address of that array can be accessed by combination of rows and columns. So if you would like to, for example, access the first one, is going to be row 0, column 0, and this one, for example, row 1, column 1, because it is the second one here from the columns, and the second one from the rows, and so on. So the multi-dimensional array has also starting from the first element to the last element, which is if you talk about 0 0, this one is not going to be 3 3 3, of course. It's going to be 2 2, because 0 1 2 and 0 1 2, so it's going to be 2 2, which is the index range n minus 1 as well. So here in this example, I'm providing different types of arrays called associative array. And associative array is an unordered collection of data elements that are indexed by an equal number of values. These values are called keys. So you can actually have the values, and then they have create keys for these values. If you look to this example here, you'll see these are states like Alabama, Alaska, Arizona, Arkansas. All of them start with A, but the keys for them is like AL, AK, AZ, AR, which is actually each one of these keys pointing to a specific value in the array. So these user-defined keys must be stored in order to access the specific value. They have some design issues in case you would like to use the associative array that you need to understand, which is what is the form of reference to the elements. Also, because these array also are user-defined. The user defines, and the user actually decides which key is going to use for which one of these values. So also one of the design issues is the size static or dynamic, the size of that array. So for example here the keys are only 2 characters. So can we make them like 1 character? Of course we cannot, because we can, if we have used 1 character, it's going to be like AA, which is here I have different values for it. So some design issues for these arrays can be seen in these associative arrays. There is built-in types in some specifically like scripting language like Perl, Python, Ruby, and Swift. All these built-in associative arrays can be used. Like they use specific symbols to reference to specific values. Specifically when using system programming language like DOS also, for example, they use these kind of associative arrays. In some commands like del, D-E-L for delete, CP for copy, MK for make directory. So some keys are used for specific commands. Same because these commands in DOS and in other programming language that they use to create operating systems, they have a bunch of commands built in an associative arrays that they use specific keys in order to execute these commands. In Perl, for example, also, and PHP also, PHP, we can give some examples right here. But in Perl, for example, the names begin with percent, and literals are delimited by parentheses like this. In this one, this is the array name, in which we have like some days of the week, like Monday, Tuesday, Wednesday, and each one is pointing to specific value. So this one is either pointing to 77, Tuesday is 79, Wednesday is for 65, and so on. So this subscripting is done using braces and keys like this. If you would like to get a specific value for Wednesday to assign, for assignment, I would like to reassign Wednesday instead of 65. I would like to give it 83. So you can actually use the name of the array, and then between braces and quotations within that value equal the new value, like that. So and also elements can be removed by delete command. If you use delete, and then the name of the array, and then also between 2 braces and 2 quotations, this value that you will delete that specific value from the array. I have an example here provided in not in Perl but in PHP. I can show you. I have an example in PHP like this one. For example, I have let me get a file here that has arrays. I think this file here. Yes, this file is in PHP, as you could see. and then I have an array called age, in which the array name is age, but it is assigned to this with the array keyword, but we assign some values for these values. For Peter is assigned 35, Ben is 37. Assume that the age of Peter is 35 years old, Ben is 37 years old, and Joe is 43 years old. So I'd like to display this to the screen. I can use the array. This is string, literal, of course, and then the array name between two brackets is the value. And once I do that, actually what I'm doing, I'm getting the value that Peter's pointing to, which is 35. So I'm gonna get like Peter is 35 years old, Ben is 37 years old, Joe is 43 years old. So these values, as it has been pointed here in the parallel, which is very similar to this example, can be used for this. Let me just try to execute it and see how it shows here. In this example, I can execute in my program. Here it is localhost, and then array, which is the folder, and then array 4.php. It displays these values. So if I would like to change something, I can change that. For example, this one is 22, okay, and then I can just refresh my program here and show that Peter is 22, and so on. I can change Joe is whatever here. Change this one, instead of 47, make it 50. Instead of 43, make it 56, for example. Save the file and then refresh the program, and then here it is 56. So as you could see, that value that we were able to retrieve is using this kind of associative array. Yani, in a nutshell, 22 is associated with Peter, 37 is associated with Ben, 56 is associated with Joe, and so on. This is what it means for this for these array types. In different languages, we can delete them with different commands, but in Perl, if you'd like to delete a specific value, you can use del or delete. And then we can move to talk about this, what is called record types. A record type is possibly heterogeneous aggregate of data elements in which the individual elements are identified by names. We call it a record name. It has some design issues, which is what is the syntactic form of reference to the field, and also are elliptical reference allowed or not. There is a lot of issues with record types, but it is also very convenient in sometimes. I will give an example for that in PL/SQL language, for example. But before going there, let me I have this example in which we have a record type. This declaring a whole row in database, for example, as a record. You can see here in the second line, I'm declaring a variable called mRecord, employee record, which equal to the table percent row type. Table percent row type means the record type. Record type or row type is the same. That means any value in the table that is declared or constructed or inserted as a specific data type, this line is capable of knowing it. Let me just give you that example here in this one. For example, I would like to describe employee table. Okay, and then please look at the data type for each one. I'm giving you this example because the record type is basically very convenient in using it in such programming. Here, let me it's taking a little bit of time to execute. Describe. Yeah. Look at the data type, but this data type is for individual elements or individual it's called fields or columns. Yeah, this is number, this is number, this is date, this is varchar2, this is number, like that. But when you use, for example, I would like to know the type of this salary. It's a number, it's a digit, yeah, digit or integer. For employee name, what is employee name? I have employee name here. It's text or varchar. I can use this record type in this example that I was trying to explain here. Here, row type for any one of these values. Yani, for example, I would like to display the employee name using the record type. Irrespective of that, it will actually tell me what is type by displaying that type to the screen. For example, that name, that specific name, which is Alan here, assigned Alan, is getting salary. Which salary? It is going to be the number. So here, when I execute this, it's going to give me Alan is getting $1,600, for example. All right, I can keep on using that. Let me just change this one to somebody else, like Smith, for example, and then try to execute again. This will tell me another line, which is Smith is getting $1,000. But I'm going to keep adding a record using my record type. My record type, which is this one. This is the record type. I don't know what is the data type. It could be character, it could be date, it could be anything. But let me use date, for example, higher date here. Okay, higher date, which is I can use this and hired on. Let me concatenate that record. That is the record type, which is I would like to get the higher date. Dot higher date. So here I'm using three different fields, which is employee name, which is a character, salary, which is integer or a number, and higher date, which is a date. So if I run it, I can get this one, which is hired on higher date. Maybe higher date is misspelled. Let me check it. If it is misspelled, I have to correct it. Describe emp higher date. It is spelled correctly. So if I would like to select all from that table, I would like specific employee. This employee is Smith. Smith, where is he? Smith is hired on 17 of December 14. So let me change it in, and then here select these, select e-name, salary, and of course higher date. You include it in your select statement so that you can also include it in your record type. Here also you have to use the record. This is what's called PL SQL, which is procedure language of SQL. So just I'm trying to show you here in this example how a record type can be used in some programming languages. Here I'm going to use the same thing: record type, record type, record type, record type. Here is record type. It is declared with what we call row type in this language, in this programming language. So here, when I run it like that, it's giving me the whole value that I needed. Smith is getting $1,000 and hired on 17 December 14. If you change that to anybody else, like John, if I have John, then will give me a different no data for John. How about King? I have King. I can say King, and then King is getting $5,000 and is hired on 17 November. So anyway, I was able to get the data, this one and this one and this one, using what? Using one single declaration for one single record, which is called employee record. I can name it anything. I can use this any name. But what the important thing from this discussion is that you are using one single type, which is you are not using number, you are not using higher date, you are not declaring it with higher date or number or anything else, like maybe some other programming languages. And for example, in this, let me show if I can have another example here that shows this one. Yeah, this one, for example, is declaring a lot of variables. It says, tell me the employee name, data type, and the salary data type, and so on. And if you have more, you can do that. But in this example, I was just showing that only one record. This is with respect to the record type, which is heterogeneous data types, but can be used by specific name for the record type. The definition of records in COBOL uses some level numbers to show nested records. Other languages, they use recursive definition, but it looks like that we use the ordered list or unordered list, which is like this. For example, here I have the first level, and here the second level, and here the third level, and so on. It can go on and on. So these three values belong to this upper level, and these two upper levels belong to the first level, and so on. Here I gave you an example like this, which is if you look at this bullet listing, like here I have the first level A, 1, 2, 3, first level. So 1 equal A, 2 equal B, 3 equal C. But the first one, which is A itself, is divided into 3, A, B, C. And A, B, C is A equal 1, B equal 2, C equal 3. And then this one itself is divided into 3, or can be broken into 3, which is I, double I, triple I's for the Roman numbers, which is again 1, 2, 3. So it could go on like that, which is, this is we call level numbers that can be used for record types in programming language COBOL, which is a business programming language, by the way. Specifically, they use it with Excel and Access applications. With regard to references to records in COBOL, we can refer to them by the field name of record name of record name 1, record name 2, and so on. We can use the of this one, of that one, of this one. And in real world, you can refer things to their belonged values by, for example, you can say the Jubel of Eastern eastern province of Saudi Arabia, like that, for example. But also you can use dot notation. يعني here dot notation means the record 1 dot record 2 dot record 3 and so on. In this regard, in that example we provided, instead of using that analogy, you can use like Saudi Arabia dot eastern dot Jebel to get to this value, which is Jebel. So they use dot notation. And also there is fully qualified reference. That means you include all the record names without using dot or without using of notation. Elliptical reference, this is allow leaving out some names as long as the reference is unambiguous. So for example, in couple, you can use any one of these. You can use first, it is distinguished and known, or first of employee name, and first name, first or first of employee name, yani first name of the employee name, or first of employee record, which is referring to the employee first name, all of them. So as long as it is unambiguous, it is clear, it is transparent, then we can use this, what we call elliptical reference, to refer to these values wherever they are. In terms of evaluation and comparison to arrays, we can say that records are used when collection of data values is heterogeneous. And if heterogeneous means they are of different data type. Different data type means some of them are, as I have shown you earlier in this example here, heterogeneous means they are different. Heterogeneous means they are not of the same type. Yani for example, king is a character. 5,000 is the number. 17 this November 01 is a date. So they will have different data types. So records are used when a collection of data values is heterogeneous. And also access to array elements is much slower. When you would like to you would like to access these elements in the array, it is slower than accessing the fields themselves, because the subscripts are dynamic, so that the fields are these fields are static. They are static. In this example, for example, if it is better, of course, let me just write one statement that uses static descriptions, which is instead of using record, you just use a select statement like that and get the same statement. Instead of all this this program, you can use only this statement, which is select ename, and then why not you concatenate again like that. Select ename, sorry, here, select remove king and put ename, and then concatenate this one with remove 500 and put sal, and then concatenate this, remove 17 November and put higher date. This is more convenient, more faster, of course. Select employee name, and then concatenate this string to the another value, which is this field. Okay, and concatenate it to this, and then from emp And then here you can use select that one single value, like where ename equal king. So compare this value I'm going to get with this statement. So if I highlight only this one and run it, is only complaining about quotation, but I'm going to fix it. Select ename is getting, and here this single quotation right here. Okay, here it is. King is getting $500 and hired on 17 December, which is the same value that I'm getting here by executing this this statement right here. So what I'm saying is that, to explain this point here, that records are used when collection of data values are heterogeneous, and also when access to the array element is much slower. فعلا يعني this is one of the evaluation. If you'd like to evaluate this one, you can say that in one of the disadvantages is that access to the array elements is using record is much slower than accessing individual records by the individual fields, because these subscripts are dynamic, but the fields names are static. They get the same value, they don't change. And also the access of individual records in all different languages is much more faster than accessing the record values, because individual elements are individual, separated, but record values, because of this data type that is assigned to it, it could be a little bit heterogeneous and different. And some of them are characters, some of them are date, some of them are numbers, and that is creating a lot of slowness in the retrieval. If you like to implement these record type, then you can actually have a record name and the type and offset. Offset means the difference between the first record and the second record. Yani every record has an offset. Offset means the separator between the first record and the second record. But every record has a name, has a type, has a name and has a type. Yani the name of the record and the type of the record, which is what kind of data it includes. The tuple types is a data type that is similar to the record, except that the elements are not named. Yani they don't give them names. They are used in some language like Python, modeling language, and F#. This is basically to allow functions to retain multiple values, because we know that function can retain only one value. Like usually, if we are in some of these languages, you can have, in Python, for example, you can create a function that retain multiple values. It is very closely related to the list items. For example, here, if you have this tuple type, it doesn't have a data type. It doesn't have a data type, but it can have values. And if you look at the values are also heterogeneous. Yani this is an integer, this is double, and this is a character. So it is actually heterogeneous, which is each one from a different data type. And they are referenced by this subscripts L, like list. And you can use catenation with a plus sign, and you can delete them with a del command. And in the modeling language, for example, you can declare this. This is very similar to the Python, except that in Python we have we don't have a data type. Here we have this val as a type value. My tuple equal these three values, 3, 5.8, and apple. So how do you access them? Number one is the first element, and you can assign new type we can define a new tuple type by the keyword type, and then the name, and then equal int multiplied by real. But this is not a multiplication symbol, by the way. It is just a separator. يعني this is just this asterisk here is a separator, is not a multiplication in modeling language. You can also use the let command, like let tuple equal 357. This is of the same type, like integers, or let a b c equal tuple. Now in this order you are assigning the 357, which is a list of items, to the tuple, or tup as a name, and then you are actually storing this one into ABC in order. That means 3 is going to be for A, 5 for B, and 7 for C. So this one assigns a tuple to a tuple pattern ABC, in which the values that have been declared will be in the order they have been written. And this is basically in the F# language. The list types in Lisp and the scheme are delimited by parentheses and use no commas. Yani if you look at this example here, ABC and A, then ABC between two parentheses D. This is an example of list types in Lisp and the scheme programming language. The data and code have the same form. Yani this is the data. And this is the code, which is very similar. But how do we differentiate between them? Yani, for example, a data ABC is literally what it is. A code ABC is a function applied, is a function A applied to the parentheses parameters A to parameters B and C. And if you look at these, this would be the parameters of the function A. And this is a function and this is its parameters. So the interpreter needs to know which a list is. So if it is a data, then we have to quote it with a single apostrophe like this one. And every data should be like, if you see this apostrophe before ABC between parentheses, that means this is a data. Okay, and look at this here. For example, in the list operation, this is in a scheme programming language. So the list, for example, car retains the first element of its list parameter. If this is a function called car, and then this is the data. So this one, for example, retain A. And put the apostrophe here before the parentheses. CDR function retains the remainder of list parameter after the first element has been removed. And if you have this example, CDR apostrophe ABC retains BC, that means if it retains BC, then the first data element is removed. So it retains only B and C as the values for that function. Cons function, in this next example, cons function puts its first parameter into its second parameter, a list, to make a new list. Yani for example, this function cons A outside with a apostrophe, and then between two parentheses we have BC. If it retains A, B, C, so it retains actually more than the parameters inside the function, which is retained now A, B, C instead of just BC. That means it puts the first parameter, because this parameter is considered the first parameter. But how does it interpret and manipulate it? It puts its second parameter. It puts its first parameter. What is the first parameter? Into its second parameter. The first parameter here, this one, it make it second. It make it second parameter, and it actually make a new list which is ABC. So it merge the nested parameters with the outer parameter A. List retains a new list of its parameter. If you have this, for example, apostrophe A apostrophe B apostrophe CD between parentheses, this retains A, B, and then CD as parameters of these two of this function list. So here list returns a new list of its parameter. The new list of parameter is going to be A, B, C, D. So the confusion comes from the fact that here these operations, they are the data is the same as the code. Yani the data and the code is almost the same, but the data is being denoted by apostrophe, and the function, these functions are built-in function. Car, CDR, cons, then list, all these are built-in function that they can have data, and then they can have processing, and they return some values. In modeling language, lists are written in brackets and elements are separated by commas. Yani here, for example, you put them between brackets and separate them by what? By commas. But they have to be of the same type. Yani either all of integers, all of characters, or all of them are float, double floating point, or any other type. In the scheme cons function, this is cons is a function that belongs to scheme programming language. It's a binary operator in modeling language, so you can use actually double colon. So if you use 3 double colon 579, so it's actually this one evaluate to 3579 in the end. And so the scheme car CDR functions are named HD and TH in modeling language. And in modeling language, instead of using CDR and car, we use HD and TL respectively. Yani here in F# also, F# list, like those of modeling language, except that elements are separated by semicolons, and HD and T1 is actually T. This is T1, not TL. HD and T1 are methods of the list class. So they are separated with what? With commas, like using commas between them instead of separating them with. And here they are separated in the list and modeling language. In the list elements, in the list programming language, these are separated by commas. In the modeling language, they are separated with colons. But in F#, this is like the modeling language, except that they are separated by semicolons. You know the difference is that instead of comma like that, we separate them with what? With semicolons like this. This is the difference between them. So in the Python list, the list data are also served as Python array, but different from scheme and common Lisp and modeling language and F#. So Python lists are mutable. Mutable means changeable, like a variable, and it can be of any type. It can be of any type, as this example here. For example, in Python, you have 3, 5.8 and grep. You see, this is a string, this is a floating point, this is an integer. So the Python list elements are referenced with subscripting with indices that become beginning at 0. So for example, same like in other programming language, if you have 1 here, like x equal my list 1, my list 1 refers to the second element of the array. So the second element of the array is what? Is here 5.8. So this one here sets x to 5.8. And also you can delete it with del command. This is in Python, the scripting language. Union types is a type whose variable is allowed to store different types values at different times during execution. Yeah, and during execution, you can use also union types so that you can store different types, different data types. This is have a major design issue, which is how do we know that which type checking is it must be required? How do we know which one is required, which one is not required in the union type? And this design issue can be of major programming obstacle sometimes in union. Unions in F# also can provide such example here, as we can say that also we can use semicolon here, two semicolons to delimit or separate the declarations lines. Here you can assign A to 7 by using let A equal 7, let B equal grep, and let X equal match, and this is two parameters, which is either match with two parameters, and then with also you can concatenate 4 as a value, and you can separate, as we said before, with commas, separate them with commas, and then assign a different value here, like apple that point to apple, and grape that point to grape, and so forth. So this example in union has different types of declaration, and as you could see, the three lines. This line is declaring A as an integer. This line declaring B as a string, but this one declaring X as heterogeneous types. Is using a function with parameters, and also using individual elements reference for these strings for different fruits, for example, in this example. And if you like to evaluate union, the free unions are unsafe. Also do not allow type checking. Do not allow type checking. You cannot type check. You cannot change one programming language from one data type to another data type during program execution, because you don't know, they are heterogeneous. You don't know which one is which one, and that actually put burden on programmers sometimes using union types, because they have to actually refer to the manuals to know which type is being declared or assigned in the beginning, and then keep changing that according to program processing. So that's why we can say that one of the major shortcomings of unions is that it does not allow type checking. Java and C# do not support unions, and also C as well. So there is some growing concerns for safety in programming language in using union types. Pointers, however, which is easier to use than others, because union type has a range of values that consist of different memory locations, and provide some power to indirect addressing. It provides a way to manage this dynamic memory location. So simply, a pointer can be used to access a location in the area where storage is created. We call it heap. So some of the design issues for pointers: what are the scope and lifetime of a pointer variable? Scope means, is it local variable? Is it global variable? Is it a parameter? That is one of the design issues. And also, what is the lifetime of a heap dynamic variable? At which point this variable is used? Is during program processing, during compilation, or in case of functions, for example, during function passing or function calling. These are design issues that can be thought of talking about pointers. Are pointers restricted as to the type of value to which they can point? These pointers, are they restricted only to the value that they can point, or they can actually point to different values during program processing? Are pointers used for dynamic storage management, indirect addressing, or both? Can these pointers actually used and be able to store in their location some values that can be used for future pointers of these values. Should the language support pointers types or not? Should the language support pointer types, reference types, or both? So pointers refer to the location where the value sits. Reference refer to the value where these variables have reserved memory location as well. So there is some sort of similarities between pointer and reference types. There is two fundamental operations in the pointer in general. So these are called assignment and dereferencing. Assignment simply is used to set a pointer value to some useful address. That means it's storing a specific memory address, and that pointer refers to. Dereferencing is actually retrieving or use this value stored in that location. Yeah, two operations: storing the value in that memory location, getting the value out of that memory location. These are called assignment and dereferencing. So the dereferencing yields the value stored at the location represented by the pointer's value. So dereferencing can be explicit or implicit. And in C++, we can have this explicit operation through using the star. Yani J equal star PTR, for example. That means J is referring to the place where the PTR variable is stored in the memory location. So this J is a value located at this location, PTR, as stored there. So to illustrate the pointer assignment, you can see that the pointer 7080, the value 7080 sits in the location where this variable is reserved, and then the value 7080 there is the address of this pointer, and then the value is 206. So actually the pointer 7080 hold the value 206. So if J is pointing to the place where the pointer is stored, which is 7080, then we're gonna go to the 7080 address and get that value that sits there, which is 260. So the value 206, I mean, which is in this case the value of J is 206. Like for example, let me just give you an example in real life. For example, you are in a plane full of 300 passengers, and somebody come in the plane asking for a specific person. A specific person. He needs that specific person to get off the plane immediately. So usually he can go to the ticket office and get the seat where that passenger is sitting, because everybody, when he goes to the plane, he takes this boarding pass. In the boarding pass there is the seat number. So for example, he looks for a person called Michael, and then he will go to that Michael. He will go to this ticketing office and tell them, where is this Michael so and so sits in that plane that about to fly. They tell them he sits in seats 70C, for example. So they come to the plane, and instead of asking for that person, or instead of actually trying to look for every single seat for this person, they straight go to 70C, which is known, and get that person from that location, right? So this is actually pointing the seat, the seat printed on this boarding pass is pointing to the value, which is the person who is sitting in that location, or in that seat, if that makes sense to you. So there is some problems with pointers, which is dangling. We call them dangling pointers, dangerous pointers. So a pointer sometimes point to a heap dynamic variable that has been deallocated. يعني this is very good to actually talk about that example I gave you about the plane. This is one of the issues. What if they came to the plane? I found that the plane authorities, the host, they change that place of Michael. They put him a different place, or they swap his seat with somebody else. It's going to be an issue, right? So they don't find him. So this is one problem with the pointers. Lost heap dynamic variable. So an allocated heap dynamic variable that is no longer accessible to the user program, which is called garbage. For example, garbage means this value has no value. This value is gone. This value is damaged. This value is broken. All right. So what is going to happen? So this pointer is set to give you a new created heap dynamic variable, which is this newly created variable might not be the accurate variable that you're looking for. So the process of losing this dynamic variable is called memory leakage, or loss of the value on that location. In C++ and C, the pointers are very flexible, but they have to be used with care, because they can be pointing to any variable regardless of where or when this was allocated. And the use of dynamic storage management and addressing also is very useful. They can also point to arithmetic operations done or expressions. So pointer arithmetic is possible. Pointer arithmetic is possible means you can use this pointer to multiply by, divide by, subtract from, whatever you like to do. Name it. Anything that operation is possible. Explicit differencing and address of operations also is possible. Explicit dereferencing and address of operators. Dereferencing, that means you extracting the value of the address operation, whatever operation is being done with that pointer. Domain type need to be fixed. Like if you put void star, this can point to any type and can be type checked. Void star, which is void, means is not it doesn't have any specific data type to reference. It could be any data type, any type. You are pointing with this star to a void, which is void means there is no data type for this value, but that data type could be anything that can be extracted from that location. In C and C++, as you could see here, you have an array declared with the data types float, and it has 100 values, and you have this pointer called P, star P, which is a pointer, is also double, which is double, which is a floating point as well. And B equals stuff. So stuff now points to the value via this this one is declared or stored. When you use pointer star P plus 5 in this array, this is equivalent as if you can say that stuff 5 or P5. So you are actually using or assigning the variable stuff to the variable P, which is a pointer for this value. If you use P plus I, for example, with the star outside, this is equivalent to as if using stuff I and PI as well. So this is in C or C++ the same. Okay, so these are some if the time allows, I would have brought some example in C or C++, that might be in the next class, might provide some example of this pointer processing in C and C++. But I would like to stop this video now, and from the next video I would like to start from this slide, which is the reference types, and to the rest of this chapter.